more formally introduce James and Randy, also from Pinecone here, Greg Kogan, who is our VP of Marketing, just said hi in the chat. You may have seen emails from him or seen other content with him in it, so wanted to make sure he was introduced.
Okay. So, shall I start, Sophie?
Yeah, so I'm just gonna quickly introduce folks. So James is our senior developer advocate here at Pinecone. Randy is the head of developer relations over at Streamlit. He will be presenting about Streamlit and how it can help you build an ML-powered question answering app in a day. And James will be going over open domain question answering and doing a bit of a demo showing how Streamlit and Pinecone can be used together to build a Q&A app. And from there, I will pass it on over to James.
Thanks, Sophie. We're just going to start by talking a little bit about the use case that we're exploring in this presentation. So we're going to cover something called question answering. And the first question I think a lot of people have is, you know, where can I use this? Why should I care about it? And so on. So as to why do we care? Question answering allows us to more intelligently search through a lot of documents. So if you imagine how many companies in the world have a lot of text-based or language-based documents and data, obviously there's a lot. And question answering this is just one use case. There are many others. In this use case, question answering allows us to essentially enable a intelligent search through those documents. So in the same way that you might ask someone a question, you just ask them in like normal, natural language. You don't even really think about it. You just ask a question. You can do that with intelligent question answering as well. So it really makes searching for things and information retrieval more natural and more human. So in that respect, in all of these companies that have these documents, if you apply this and allow their staff, for example, to search through those documents in this natural way, you have the potential to save a lot of time. And obviously minimizing the amount of time that people are wasting searching through potentially hundreds of documents. It is a pretty good use case and can make a big difference. So another thing is, you know, how do we actually use something like this? So that's what we're going to show you today. But at a very high level, we're just going to show you like a simple search interface. So imagine like Google, we're going to make a little search bar and we're going to type things in, press enter, and we'll get some results. It's using natural language prompts, so you don't need to, or at least I've seen in a lot of cases with internal search engines, it's very difficult to understand how to use it, and it's very unnatural. In this case, it's not going to be unnatural. It's going to be very natural. We're just going to ask a question. And it's going to be powered by open domain question answering, so that ODQA. And we'll explain that a little bit more as we go through the session. So yeah, we're going to show you how to build it. It's really quick. You can, I think in most cases, build it in a day. Show you how it works, and intro to Streamlit. And then obviously we'll go through all the open domain question answering stuff, which consists of 3 components, which we'll go into a lot more depth in a moment. But that starts with the Pinecone vector database, retrieval model for information retrieval, and a reader model for highlighting. So we'll jump into that. So at a glance, I've already sort of briefly touched on it. So we have on the left, we have the sort of front end UI, which is powered by Streamlit. So there'll be a few different components in this to really show what you can do with Streamlit super easily and quickly, and really show all of the features of open main question answering with Pinecone and these other models. So that's the front end. We have Streamlit. We'll see how all that ties in to the back end, which is on the right. So the back end, this is a very stereotypical question answering pipeline. So we have the Pinecone vector database where we store, it's a database, we're storing all of our data, which we'll show you, but it's essentially a load of text that we've scraped from different technical forums, so like PyTorch, Streamlit, Transformers, and so on. So we're going to store all of that text data in our vector database, but it's a vector database. It's not a text database. So we need a way to convert those into, or convert that text into vectors. And that's where the retrieval model comes in. So the retrieval model is almost like the first point of contact for our app. So we make a search query, and that gets converted into what we call a query vector with the retrieval model. And the same for our context as well, which are the paragraphs from the forums that we store in the vector database. And then after we have used that retriever to pull relevant context to our particular query, we can actually highlight the most relevant parts of that context, because the context is typically like a paragraph or something, so it's relatively long. We can use a reader model to highlight a few words that answer the particular query that we've asked. I'll pass over to Randy, and he'll introduce Streamlit.
Thanks, James. So in terms of the demo that's going to happen later, it's obviously a very advanced sort of technique in Pinecone's an advanced technology. But at first, I'd like to talk about why does Streamlit exist at all? And so when we talk about what types of apps that data scientists might need, or machine learning engineers, or even enterprises, the group doesn't necessarily matter. You can think of this sort of analytics problem as a four-step process. You have your data, you're going to train some. In the case of NLP, you might be using pre-trained models by somebody else. And then, you want to put this model into production for some use case. Can you click the... Okay. But in reality, business is always, a lot more complex than that. There's lots of different use cases where you might want to have a dashboard, do exploratory data analysis, demoing a model like we're going to do today, creating, simple text-based processing tools. All these sorts of things help us communicate our results to our stakeholders, as well as make life easier for us to, do our work. Next slide. But the problem with existing tools is that building data apps can be slow and frequently expensive. Prior to Streamlit, it might have taken weeks, potentially even months to develop a single data app. And with that, those costs made it so that perhaps only a fraction of all useful apps were even created. And so we look at this from two potential workflows. The first workflow would be that the data scientist or machine learning engineer would build the app. And so you might do some work in a Jupyter notebook. Once you figured out exactly what you want to do, you might copy that into a Python script. Then, you can use Django, Flask, HTML. You could code this in JavaScript if you knew it. And then, you present your work to your stakeholders, and of course they have feedback. And so now you run into a situation that we've, called the unmaintainability trap. Your specialty is not maintaining and developing web apps. It's, in some technical discipline. And so once people start giving you feedback and asking for new features and things, it's not really clear who would do that, right? You've got your engineering work that needs to be done. This as a prototype, may not have a stable home, a stable server. And so, in this case, you can't really update the app. And then the people who, want more clarification or want more features end up not getting what they want. And so that's one workflow. The second workflow could be that the engineer hands off, their code to a tool building team. And so, of course, when you're not the person who's done the analysis, the only way for this to work is to, go through this sort of waterfall or agile type process where you start collecting requirements. Designer has to lay out the wireframes. Some other group of people start coding in JavaScript. And then, if you're lucky, a month later, you might have a situation where the app now exists. But now you're in a situation where, because you had to procure all these resources, the app is somewhat frozen, right? As the machine learning engineer, you didn't code the app. You procured all these development resources, but they're not assigned to you. And so something needs to be changed, but now you have to go through the process again. You have to, make the case that your project is more important than another one, get the developers going and so on. And so now your app becomes frozen again, and so this is, either workflow here historically has led to, potentially fewer apps than you might have otherwise. Next slide. And so Streamlit was developed to be not only the fastest way to develop, but hopefully the easiest way to develop data apps by taking some of the basic elements of Python and, having a declarative interface. We can, really dramatically reduce the time to creating apps. And as James mentioned before, in combination with tools like Pinecone, you can have a situation where, you start, even after lunch, and potentially by the end of the workday, you've created a very powerful data app. Next slide. And so the way Streamlit was developed was based on three simple principles: embracing Python scripting, treating widgets as variables, and then reusing data in computation. And so we'll go through each of these, and then hopefully at the end, it will make sense that how Streamlit is different than perhaps other web technologies that you've used. So the first part is embracing Python scripting. And so Python has, over the last decade, really ramped up in terms of its use in science, technology, engineering, machine learning, and so on. And as I mentioned, you may do this in a Jupyter notebook. You might do it in a IDE. That much doesn't much matter. But Python is a much different workflow than coding a web app. And so Streamlit was developed by machine learning engineers to work inside of that workflow. And so if you've already solved the problem that you want to do, you've already created your app, or excuse me, you've already created your model, you want to understand how that model works, okay, you probably have some Python code already. And so Streamlit was developed so that you could add just a handful of lines in various places in your code and build interactivity. And so in this animated GIF, you can see we have a couple of widgets. The STWrite widget declares, I want to have a title called My First App. I'm also going to write Hello World. You'll notice that it looks kind of markdownish. That is intentional. That is markdown. And so if you want to format your titles or anything else that's valid markdown syntax, you just immediately declare it and it shows up on the screen. The second piece of reading in data, of course, that comes directly from pandas. That's not a Streamlit function. And then if you want to have a line chart, again, we just declare the line chart, pass the data frame over, and now that exists on your screen. And so the whole intent of making Streamlit fast and easy to get started with really is this declarative workflow. I want the output to be right here, at this part of my script, and then, it automatically shows up in the browser. The second piece, the second design principle for Streamlit is treating widgets as variables. And if you've ever done any work with JavaScript, you'll know that a lot of it works with callbacks. And callbacks, provide really amazing flexibility in terms of how you can tie a input widget to do something else on the page. But that type of thinking isn't necessarily easy for machine learning engineers. Machine learning engineers tend to have a much more linear order where your code starts at the top of the script, it runs through the steps in order. You may potentially go back and revamp your model and things, but even then, you can think of the steps as sort of this very serial order. And that's how Streamlit works. So instead of having to define callbacks to tie every input widget to do something in the script, instead what we do is every Streamlit widget, every input widget returns its value as another Python value. And what this ends up giving you is a situation like you have here. So if we declare our title, apps with widgets, then we want to put a slider. And so we have the st.slider line, we give it a heading, and then you see that it's assigned to the variable x. In this case, the variable x is the value that you're seeing on the page. So going from 24 to, I think this goes up to what, 80? X can take on any number of values. You can now pass that value forward to a write command. And so now that value of X is immediately available elsewhere to the Python code. And then, here we're doing a fairly trivial, just writing the value. But it's just that simple of being able to tie an input widget to an output widget within Python. And so the third principle for developing Streamlit was reusing data in computation. And so if you're thinking about this workflow of running top to bottom, you've probably seen this in a Jupyter notebook where you get to this situation where you have a handful of steps that are so expensive to run that you do anything not to run the notebook from top to bottom. Of course, this runs into a situation where you can have a hidden state in your notebook, which can unfortunately lead to not being able to reproduce your work. So Streamlit runs top to bottom, except for a few specific cases. And so in a case like this example is showing that we want to load our CSV. And so usually this is probably a one-time situation, whether it's a query to database, loading a CSV, and so on. You load the source data once and then you process it. And so, if you have gigabytes of data, this might take 10, 15 seconds in pandas, maybe it takes minutes. And you don't want to do that every time you rerun your code. And so by selectively caching steps, what we're doing is telling Streamlit, we expect this input to be a constant over time. And so we want to store this in RAM so that instead of having these 15-second or minute-long pauses in our app, we're just going to keep those results in memory. We're going to run top to bottom. we're going to run our code as if it was running top to bottom, but instead, when it gets to that step, it pulls the result from RAM instead of actually running it. And so what that allows us to do, as I said, is cache these complex or long-running steps, but still think of our code as running from top to bottom. And so, those are the reasons, why the Streamlit project was developed. Now I'm going to hand it back to James, who's going to show how you can integrate Pinecone and Streamlit together in order to make a custom search engine.
Cool. Thanks, Randy. So, yeah, I'll take you through a little bit of the sort of code and example of something that we have built with Streamlit. So I'll just switch over to the correct window. So this is what I'm going to show you how to make. So we just have this, you saw like there's a few components here that maybe you can recognize from what Randy has just gone through. So we have this little st_write, we've got a title, and then down here we have what is called a text input. So we just write something in here so we can ask, one of the questions that I was searching for a lot when I was putting this together was how do I create custom components in Streamlit? So I can just write, how do I create custom components? Don't necessarily need to specify Streamlit. And I get this answer. So we have more than one answer as well. That's another thing to point out. So we have quite a few answers. And when I was actually searching for this, these sources are exactly where I actually learned how to do that from. So I can click on this little button here, and it actually takes me to the original source of where this data has been pulled from, which is just on here. And we have this little video from Streamlit, which teaches how to actually do that. So this is, what I mean when I say it's a very natural way of question answering. So we're not specifying anything. We're not saying like Streamlit custom component or any weird syntax in our search. We're just saying, okay, how do I create custom components? It's like asking a question to another person. And another really cool thing that we can do is actually filter as well. So with this, maybe I want to talk about components in PyTorch, for example. Now, there's not actually a thing in PyTorch, but we'll just see if I filter on that, we then get a load of results specific to PyTorch. So I'll put that back and we'll actually go through how some of this works. So we have this little notebook, and this just goes through the sort of back-end stuff, so the actual Q&A pipeline. So first thing I'm going to do is just import a few libraries. So we're using Pinecone, sentence transformers, and transformers, which handles everything for us. So the next thing I'm going to do is initialize the retriever and reader models. So we saw in that kind of stack from before, we had the Pinecone vector database at the top. We had a reader model, a retriever model, and then we had a reader model. Okay, so here we're just initializing those. Super easy, like there's a few lines of code here. Here we're using sentence transformers library. We're specifying this model up here that we'd like to load. So just a pre-existing model. We don't even need to train our own model here. And then we're specifying a reader model. Again, it's pre-existing, we don't need to train it. And we're loading that with the transformers library. So we have two of those components now, the retriever and reader model. Another thing that we need for this particular use case, because some of the text is quite long, not all of it, but occasionally we get some long text. So what I've done is stored some of that locally. So it's either locally on my machine, or if I'm running this in Streamlit Cloud, it gets stored in Streamlit Cloud. And this just contains a mapping of IDs, which we will return from Pinecone later, to the actual context or the paragraphs that we're going to be returning. So we'll load that as well. And I'll show you just one example. Okay, so this is similar to what we saw before, the making your own component thing. It's just returning as a little bit of text. So that's most of it. The only thing we need to do now is actually initialize Pinecone, the vector database, and load this here, which is my particular index or database that contains all the vectors for this particular use case. So I'm going to run that. So I'm initializing Pinecone here, connecting to that index. And then here I'm just describing the index. So I'm looking how many dimensions do my vectors have, how many vectors do we have in there. So we have just over 200,000 in there. Next, I want to, same questions for how do I create a custom component. I'm going to take that as my query. I'm going to encode it to create a query vector XQ. So run that. I'll just make sure I have the retriever up here. Run that again. Just give it a moment to load everything. Okay. So just I didn't load the reader and retriever before. Now I have, so that's worked. So XQ is just a vector. Okay, so we can quickly look at what that looks like. It's just this. It's pretty big. So it's 768 dimensions that you saw before. And now what I'm going to do is query the index that we have in Pinecone. I'm going to pass the query vector XQ. I'm going to return the top 5 most similar results. And I'm just going to include a metadata, which includes just a few essential bits of information for our use case, like the URL, the source of the information that we've extracted, which we're going to need for the Streamlit app later. So run this, and we see these are the results that we're returning. So we have our matches, we have the IDs, and then we have that metadata that I mentioned before. Okay. So from here, we have a lot of the information we need, but we don't actually have the text because we're storing the text in the text map variable. So what I'm going to do is get the IDs from here. So you can see we have these IDs. I'm going to create a list of those here. So we have 5 because we set top K to 5. And I'm going to get the text mappings using those IDs. Okay, so we can see from that query, we get the same answer as what you saw in the app earlier. Okay, so making your own component and so on and so on. There are a few of the other ones as well. So that's the back end side of things. But obviously what I showed you a minute ago is in Streamlit. So we've basically similar to some of the things you saw in Randy's slides earlier, we're taking this Jupyter notebook and then very surprisingly easily wrapped it into a web app with Streamlit. So you'll recognize a little bit of the code here. There's a few things that Randy mentioned, the caching, for example, which I've used a version of the caching in here with where you see this experimental singleton. So the models, we don't want to reload those every time we do anything in our app. We just want to load them once when we load the app. So that's what I'm doing here. So I'm initializing the retriever. This is stuff you saw in the previous notebook, initializing a reader model, initializing that key value mapping variable, and also initializing the connection to Pinecone. A few other things I'm doing in this little bit here is extracting the dimensions and the counter vectors from the index stats that you saw before. I'm going to use that and display that in the app so we can just kind of see some interesting information about our index. And then coming down here, I'm just specifying a few things like the libraries that I'm going to be using or the libraries that I'm going to be pulling data from. This is important for the metadata stuff that we saw before. And maybe I can even show you, point a few things out in the app whilst I'm going through the code. So these libraries, we can see those being pulled in just here within the metadata filter. So we have Streamlit and all these other ones. And obviously, we use that in our filter later on. Here, we're just reading or initializing those, the parts I mentioned before: Pinecone, retriever, reader, the key value pairs. Then we get into actually setting up our app. So if we just have a look at this, at the top we have this this ml.q&a. It's just a title. I've written it in Markdown. You can see it's just a header, and that's all you need to create. It's super easy. And then I've done this query text input. So I'm saying ask a framework specific question, and the default value of that is just empty. Also, I've entered something here and I've asked a question, and that's just passed along to query here. And then what I've added here is, or the next part of the app that you can see, literally we're going through it step by step, like super simple and straightforward to actually put together, is this advanced options expander, where we have our metadata filtering options, and we have this top K variable. We saw the top K earlier in that little script. This is all wrapped within this ST expander. So in some of our searches, or a lot of our searches, we probably don't want to use this. So it doesn't need to be like in our face all the time. We have these options. So by default, we have a close, and we have a simpler way to actually search and just ask questions and see what we return. But then if we do want to have that extra functionality, we just open this, and straight away we have this really easy and cool and powerful way of filtering out data using these different options. And then as well, if we decide, okay, for what I'm searching for, maybe I need to look through more data, or maybe I'm returning too much data or too many results, and also just change the top K here. So for example, at the moment we have 5 results returned. Maybe I just want to return 2, and that will just run straight away, and we just get 2 results back from that. So all of this code here within this with ST expander, is that what you see there? Okay. Yeah, I don't think there's much to go through there. We have the slider returning values, and the checkboxes here as well. Forums and docs. So these 2 metadata points are just where I pulled the data from initially. So some of the data, particularly from, I think it's mainly Streamlit and maybe PyTorch as well. We have a lot of data coming in from their documentation. And then the rest of them are coming from the respective forums of these different frameworks. So that's where we if we decide, okay, we want to look at documentation, not forum discussions, we can do that as well. Sidebar, I'll show you that in a moment. And we'll move on to the actual query. So this, I think, is the most interesting bit, one of the most interesting bits. But for the most part, we can't really see what is going on the Streamlit side. So, okay, we've entered this text. We can ask other questions as well. So, for example, say, how do I use gradient tape? So how do I use gradient tape? Now, this question is relevant for both TensorFlow and PyTorch. So I can type that, and I can get these results. So get a gradient tape, and these are both in. Let me increase the number of results we're getting. And these are both in PyTorch and TensorFlow, like I mentioned before. You can get like actual code from TensorFlow on how to use it. So it's pretty relevant. And if we decide, okay, we want to see a bit more, we can obviously click on the source and see where that's actually coming from and maybe explore a little bit more. But when I type that in, what was actually happening? So I type that in, we have the text input here, which passed how do I use gradient tape to the query variable. That came all the way down here. And we said, okay, the query is not empty because by default it's empty. If it's not empty, we're going to encode that text, that query. This is the same as we saw in that Jupyter notebook before. I'm going to create some vectors. We're going to, this is just kind of formatting metadata if we have any metadata. And then we pass that query to Pinecone and return some context. So we have our query here. We have, if we do have any metadata, gets passed into here. Otherwise, we actually use this query instead, which is exactly the same, just without including the metadata filters. And then this XC, there are our vectors or the small amounts of metadata, including the IDs. So we then use the text map to get the actual text, so the context or the paragraphs that we see here. And then we loop through, we're looping through each context that we've returned here. So when top k is equal to 5, we're looping through 5 of those. We're getting the text from our text map. And then we're using this card component, which is another really cool thing with Streamlit. You can, this is really simple Streamlit, and then you can also go really into the details and build custom components, which is a really fun feature and thing to do. So what we've done here is build a custom component, and it's just a card. So it's like this card that you see here is this that you see here. Okay, and in there we've included the title from the metadata. We have text, and then we also have the specific answer. So this bold bit you see here is the specific answer. Or if we come down here, we have like a specific answer here. Now, the specific answer part, sometimes it works really well, sometimes less so. So it's just like a nice to have. If it works, great. Otherwise, it's going to kind of like maybe point out something relevant to you, maybe not. But it's nice to have, so I've included that in there. And that's coming from the reader model, by the way. And then we also have the score, which we include up here, and so on. So, yeah, I mean, that's pretty, maybe it seems like a lot when you just go through it like this, but it's actually really straightforward. There's also the sidebar as well. So the sidebar, if we open on the left here, we get some nice Pinecone index details, how it works, to just describe a few things. So there's sort of the question, how do I enable GPU with TensorFlow? We can just copy and ask that. And then a little bit of an explanation and how everything works. So yeah, really super easy to put everything together, which I really liked. You know, on the Streamlit side, really easy. And you have the Pinecone side, makes it really easy. And then you're using sentence transformers and transformers. There's you hardly have to do anything. You just have to put everything together. So that's really cool. So yeah, I think that's it for the demo. We are going to share all of this, like the code, and there's going to be a demo that you can play around with, hosted in the Streamlit cloud. So we'll be able to go through all of that as well. But we'll switch back to the presentation. And there's just a few more slides actually that I put down here explaining the vector database. We'll just run through these quickly. So for those of you that are interested in like understanding how, okay, because I mentioned those components, but didn't really go into details on them. So we have obviously the vector database, which stores vectors. Imagine like you have a three-dimensional vector. We can see that, or two-dimensional vector in this case. We're just putting these like points that actually represent the text, the context, or the query in this vector space. The vector database stores these in a very efficient way. We can like deal with billions of vectors, for example. In this case, only 200,000, but you can go up to billions, which is pretty incredible. You put these all into a vector space, and then given a query, you convert that to a vector, put it in your vector space, and find the most similar or the closest other vectors to your query vector, and they're like the most relevant results that you're returning. So that's the Pinecone vector database side of stuff. And then we have the retrieval model from sentence transformers. This is how we create those vectors in the first place. It deals with both the context vector and the query vector. So the little example I put here is the query of where is Normandy should be placed in a very close proximity to the vector for the context. Normandy is a region in north of France. Right, those should be placed together if the retrieval model is working as it should. Yep. And then we also have the reader model, which I pointed out as like the bold highlight. Again, this is like it's like it's really nice to have if it works at the end. It's just to kind of draw your attention to a certain part of your paragraph. So that's just using another transform model. We just loaded a pre-trained model from Face Transformers. Super easy to put together, and that takes our query, takes our context, and it just highlights a specific span of that context that is most likely to answer your specific question. So yeah, as promised, these are the links, so to the app code, and also a live app as well that's hosted on the Streamlit cloud that you can go and play around with. And here's a few details on how you can sort of get started with Streamlit or keeping in touch with what Streamlit are doing, and also Pinecone as well. So, oh, actually, sorry, Sophie, this is for you to go through, so I'll be quiet.
No worries. Thank you both, Randy and James, for doing this. We're going to take questions now. These are some resources here, and then Charlie and Randy have been posting some Streamlit ones. Anyone that attended this webinar will receive a follow-up email with the notebook, recording, and slides. So you'll definitely have the opportunity to implement this yourself. There is someone with their hand up, I believe, and then there have been some questions. There's one in the Q&A box. Please make sure your questions are in the Q&A box, because that'll make it easier to answer right now. And we'll spend the next about 12 minutes answering questions. And yeah, James, take it away.
Yep, so I'll just answer the some of the questions in the Q&A. So the first question, could you tell us more about inferencing time? Say, for example, we have a database of millions of entries. How fast would the query be? As far as I know, transform-based semantic embedding can be quite slow to operate at scale. And we have millions or billions of entries to measure similarity on. So, so it depends on obviously what you're using. In the past, yes, it would have taken a long time. If you have millions or billions of entries that you're comparing and you're using like a typical sort of nearest neighbor search through that, where you're sort of exhaustively comparing everything. But Pinecone and uses something called like an approximate search, which allows you to basically restrict your search and like approximate by reducing the number of things that you're comparing. So even when you have millions and billions of entries, the search times are super fast. So we do have some charts on this which show you like typical inference times. I don't remember the exact times off the top of my head, but it's literally like 100 milliseconds when you're in the sort of high millions. You're not going to go too far over that, but it also depends on, we have something called pods, which are like the hardware parts behind your database. So it depends on how many of those you're using and various other things as well. So I'll go on to the second question. Greg, do you want to? Okay, I'll go on to the second question. So, are any sources easily integratable into Pinecone for open domain question answering? So, any sources? I'm not sure what exactly you mean by sources here. So like data sets or like embedding providers, maybe you can like expand on that. But in terms of like data sets, obviously you can you pull them from wherever you're pulling them from and use them similar to the code that you saw that we went through. You can do a very similar thing where you're sort of embedding or encoding your query, but rather than encoding your query, you just encode your data sets, so your context, and create all of your context vectors. Yep, and then on the sort of embedding providers, similar thing again. It's you use the embedding provider, and then you create your embeddings and then kind of pipeline them into your Pinecone vector database. We do have a few like articles and things on Pinecone and open domain question answering. So if you have a look at we have the Pinecone.io/learn, and we have well, you can see a few links on here actually. So intro to Q&A, retrievers and readers for open domain question answering, that will explain some of that as well. And then the next question is, does it have table understanding capability? For example, if I have a bunch of PDF files with text and tables, can I fetch results from tables? So it depends on basically you'll have to build that pre-processing capability. So for PDF files, they can be a little bit difficult, but there are a lot of like very good open source libraries and also paid solutions that deal with like OCR for PDFs, so you can read all text from your PDFs. Then you typically store them in like text files or some other type of file, and then you can encode them in a similar way to what we saw in this demo into vectors, and then thread them into Pinecone. For tables tables are a little more difficult. So it depends. There are models that deal with table data and even table Q&A. So I'm sure if you went ahead and applied some of those to your tables, you could probably figure something out. Otherwise, there's the possibility of sort of coding something up if your tables have a certain structure, coding something into like kind of like tables to text and then encoding that and putting them in there as well. So for the, okay, so next question is, could you please point me to the chart you mentioned showing inference times of the application? So I think on the Pinecone YouTube, we just uploaded a video demonstrating some of the, or going through the latest Pinecone release, and in there were some charts on the inference times. So I'd recommend you go and have a look at that. So it's the most recent upload to the Pinecone YouTube channel. I'm not sure if anyone like Greg or Sophie, if you have any other places you can find that and you want to share, just like interrupt me, it's fine. Otherwise, yeah, on the YouTube, there's a video that goes through that. So the next question is, are there any pre-processing codes available through Pinecone to extract any context from diverse sources like Wikipedia or PDFs? So we don't offer anything for the pre-processing side of things in Pinecone at the moment. So for that, it's a case of, yeah, using other libraries. Again, in the Learning Center on Pinecone, we don't shy away from kind of explaining and going through all of this stuff. So we have a lot of examples where we are pulling data from different sources, like processing it in some way or another. So I'd probably definitely recommend like having a look at the Pinecone Learning Center, and you'll find a few examples of how we have done it for different use cases in there as well. Yeah, so I'd recommend doing that. A lot of the time, depending on your data source, it's not too difficult, but there are a lot of really good utilities out there that make this pretty easy. Okay, there's no more questions in the Q&A. Don't know if there's anything else.
I think one person has their hand up, but that's Alberto. If you can type your question, that would be easiest for us to see it. And if people have questions related to Pinecone or related to Streamlit, where do they go?
Yeah, if you have questions for Pinecone at the very least, feel free to post those in our community page, which will be linked in the follow-up email you receive, and I just posted it in the chat as well, and will be linked in the slides too. And Randy, if you want to talk about where they can go for Streamlit, all you.
Sure. For Streamlit, our forum is at discuss.streamlit.io. We also have Discord, which is linked from our forum, and so one of the two of those is a great place to start.
Great, thank you. Wonderful. Alberto, if you would like to type your question, you have another minute or so to do that. And otherwise, feel free to post any further questions for us at any time in our community pages. And thank you so much for all of you for being here. And again, you will receive the notebook, slides, and the recording of this webinar in the follow-up email to this webinar once it is all posted online, and the email should be going out in the coming days. So there's one more question. Matthew, I think your question was answered live already. James, the question for any sources being easily integratable into Pinecone for open domain question answering.
Yeah, so we answered that a little bit earlier. So yeah, so a case of depending on the sources you mean, like embeddings or data sources, it's a case of pulling that in separately from whichever source you would usually go to.
Awesome, thank you so much. And if you want to review your questions, they'll be in the recording. You can always post in our community page. We're going to wrap up now. Thank you so much, James and Randy, and Charlie from Streamlit as well, and Greg for answering questions too. Have a wonderful rest of your day or evening, wherever you are in the world, and we look forward to having you at future webinars.
Great. Thanks for having us.
Thank you. Thank you, everyone.
Bye all.
Bye.